So I'm Damon Barnes, Director of Technical Marketing for the Bluetooth SIG. Today I'm going to give you a little bit of an update on what's new with Bluetooth technology. We're going to look at some insights, some trends, and feature enhancements. Before we jump into that part though, let me just do a quick reminder overview of the Bluetooth Special Interest Group. Actually, the agenda first. Okay. So first I'm going to give you an intro of the SIG, and then we're going to look at these market insights. Then we're going to look at some new technology and emerging trends. Then we'll look at Auracast in just enough detail to set up Henrik's talk. Then I'll give you a nice overview of Bluetooth channel sounding to set up Alvik. And then we'll close out, or I'll close out with some upcoming Bluetooth feature projects that are in the pipeline that you should be aware of if you're not already. All right, so the SIG, or Bluetooth Special Interest Group, we oversee Bluetooth technology and all associated trademarks. We're a not-for-profit, been around for about 26 years. The SIG's a little bit different from other wireless standards bodies because we kind of do everything in-house. So we oversee the standards development projects. We handle product certification, qualification of all Bluetooth products. We're also the patent and trademark license administrator for Bluetooth technology, so that we cross-license Bluetooth to 40,000 plus member companies. And then of course we're also functioning as the marketing arm. That's where my team resides and where I work, so that's near and dear to my heart. All right, so Bluetooth technology has a massive install base, as these numbers indicate. This data is provided by ABI Research. The graphic comes from the Bluetooth market update on Bluetooth.com. You'll see if you look at 2023 that 5 billion Bluetooth devices shipped. This year, ABI is projecting 5.4 billion devices to ship. And then if you fast forward out to 2028, you'll see that ABI is predicting 7.5 billion Bluetooth device shipments. And so you tally that up over the 5 years, that's an 8% compound annual growth rate. And so that's a really good number. Again, massive install base. And we're really excited to see, hopefully, these numbers materialize over time. And then so this growth that's projected by ABI to occur over the next several years is going to occur because of this continuous innovation by the Bluetooth member community. This graphic shows some of the recent feature enhancements over the last several years. These are the feature enhancements that are going to primarily drive that growth. If you want to talk just a minute about some of the use cases that the features enable. So you have mesh networking that's enabling network lighting control, direction finding from 2019 that's enabling or enhancing locating solution type use cases. LE Audio, that's the enabler for Auracast that Henrik's going to be telling us all about. You see PAWR on the slide. That would need some explanation if you're not super involved in Bluetooth. That stands for Periodic Advertising with Responses. Periodic Advertising with Responses enables very low power, large scale device networks like those you see in the image for electronic shelf labels. And so that feature is going to enable a massive number of Bluetooth devices over the next 5 years. And then, of course, Bluetooth channel sounding. Channel sounding launched early September, and so I'm going to share more about that in some subsequent slides. And so talking about the use cases that are basically a little bit more about their they're leveraging, I should say, these features. Of course, we're going to cover Auracast, digital key, and FindMy shortly, but a couple of stat predictions. So for ESL, electronic shelf labels, ABI is predicting that there will be 100 million Bluetooth ESL devices that are shipped by 2028. So a really large volume that will be relying on standards-based, Bluetooth-based electronic shelf labels. And then mesh networking and network lighting control. Here, ABI is predicting 115% compound annual growth rate over the next 5 years. So now let's take just a little bit closer look at Auracast. Okay, so Auracast relies or is part or comes out of the LE Audio suite of features. When we talk about LE Audio, we break it down into 3 main use case areas. So the first area on the left-hand side is consumer audio products like earbuds, headphones, For these type of devices, you're going to get lower power, obviously, because it's over LE. Over time, you're going to see better performance, higher quality audio from LE audio as compared to classic audio. Then the second bucket's hearing aid, hearing assistant type devices. LE audios with the HAP profile standardizes hearing aids over Bluetooth technology. So that's going to give global interoperability for these type of hearing aids, and you're going to also see increased performance or audio quality from the hearing aids. And then Auracast, of course. Auracast is based on broadcast audio, so it's not connection oriented. We talk about and we hear from the community that Auracast is set up well to be the next generation of assisted listening system. So that's super exciting. And Auracast enables these really immersive audio experiences that I'll talk just a little bit more about in a subsequent slide. And so this is kind of how we summarize Auracast broadcast audio. With Auracast, a Bluetooth device or a transmitter, it can broadcast to an unlimited number of in-range devices. And this basically enables these life-changing audio experiences. I have a slide to share a little bit more about that in just a minute. But these broadcasts, they can be open or private, password protected. The audio quality, media quality is really high. So I've had, because I work for the SIG, I've had a chance to listen in to some of these demo experiences that we provide. And just the audio is really solid, and it's like it works over a really good range. So if you ever get a chance to experience a demo, definitely check it out. And then so how Auracast works at a high level, obviously Henry will jump into this at a more detailed level. So you have your transmitters, so like a television, laptop, tablet, or PA system. That's going to broadcast the audio. And then you have your Auracast receiver, so the hearing aids, your cochlear type implants, headphones, earbuds, etc. These are going to be the devices that are tapping into the broadcast ride. And then you're going to use an assistant device like a smartphone, smartwatch, or a hearing aid type remote. And that's how you're going to basically tap in or choose the audio broadcast that you want to listen to when, for instance, if there's one or multiple available. And then I mentioned the experiences just a minute ago. We have basically 3 buckets for these experiences. So there's number 1, share your audio. This is like taking audio that you're consuming on a personal device like a smartphone, tablet, and sharing it with other people like family or people that are nearby that you want to share the audio with. And then number 2 is unmute your world. This is talking about like silent TV type use cases. So envision yourself like in a bar, inside a hotel, a football game, a basketball game is playing. You could be sitting at the bar having a drink, having a meal, and then basically unmute those TVs to take in the audio and hear the broadcast. And then number 3 is hear your best. This is all about audio accessibility. This is a good example here as the image portrays is airports. So like finding your gate, getting gate change announcements, when it's time to board. Sometimes it can be kind of sketchy to hear those, just like with your ears. So being able to hear those, take in those announcements to your earbuds or headphones will be super beneficial. Our visual, locations, I already mentioned airports, bars, theaters. These are some of the type of venues where we think Auracast can have a big impact. Conference rooms, lecture halls, conference centers. And then, so to summarize on Auracast, Auracast has experienced really good traction in the audio markets. There are a number of commercial products available today from major brands. You can see like all the images and everything. If I were to break that down into like categories just to show the level of where adoption is, I guess you could say at this point, I would summarize it something like this. So on the platform side, we have support from Microsoft, Android, Intel. On the smartphone side, Samsung, Sony, Xiaomi for Greater China. And then transmitters from Ampertronic, Hisense, Samsung, and Resound by part of GM. And then receivers from JBL, Sennheiser, Jabra, Cochlear, Philips, and the list goes on. But so that just kind of clarifies or explains the strong support there is in the market. And then like if you look at the quote there from Andrew, he points out that Auracast is expected to be a standard feature in all Bluetooth audio products, over time. So now let's switch to the new and upcoming features. So I'm going to spend a few slides here talking about Bluetooth channel sounding, giving you a little bit of an overview and talking about some of the high-level nuances. And then, like I said, I'll tease out some of these upcoming feature projects to keep your eye on that's going to enhance Bluetooth technology. Okay, so to start off with, this is kind of how you ask the question, like, what is channel sounding? The way we describe it from the SIG is something like so. So Bluetooth channel sounding is a secure, fine-ranging feature that promises to enhance the convenience, the safety, and the security of any Bluetooth-connected product. And so we know, and we already see from like interest from members and in the markets that channel sounding is going to have an immediate impact and enhance Find My type solutions, digital keys. But here's the interesting scenario to think about. What happens when you make any Bluetooth device distance aware? You suddenly have this transformative possibility for all Bluetooth connected devices. Here's a couple of examples. Bluetooth HMI devices, such as, Bluetooth HID devices, got ahead of myself, such as mice, keyboards, and game controllers. These devices can automatically switch between active and inactive states based on their distance from a smartphone, tablet, laptop, PC. And then another example here, Another example here is the HMI devices that I was trying to talk about previously. This is in more like the industrial type setting. Here you can enhance personnel safety by only allowing this heavy equipment, machines, robots to operate when the operator is at a safe distance. So those are just a couple of examples of how Bluetooth channel sounding can enhance some of these use cases and have a transformative impact on Bluetooth connected products. All right, and then so taking just a little bit closer look at starting to get into how Bluetooth channel sounding works. So the fine-ranging aspect of Bluetooth channel sounding is based on phase-based ranging. Phase-based ranging is a well-proven method for measuring distance in RF engineering, been around for many years. And then the point on security to make is this. So Bluetooth channel sounding was designed for security. There's multiple security features that are in place to mitigate the risk of wireless ranging attacks. There's multiple security levels where you can choose basically the level of security you want to implement depending on the type of attacks you're trying to protect against. And then talking about the performance, the distance measurement accuracy, which everyone is so interested in when it comes to Bluetooth channel sounding. What we're saying from the SIG side, and this is based on data early implementation testing data that we have for members, we're saying that channel sounding enables centimeter level accuracy. I'm not necessarily saying like, 1 centimeter like this, but we're saying the distance can be measured in tens of centimeters, so 10, 20, 30, 40, etc. And then so we do have an early implementation from a member that's achieving plus minus 20 centimeters of the accuracy at distances up to 100 meters. And I'm going to share some testing data that we have that was conducted prior to the launch here in just a couple slides. So that's going to be interesting to share or see. All right, and then so looking a little bit more closely at how Bluetooth channel sounding works, I want to emphasize once more that channel sounding occurs between connected Bluetooth devices. So the devices have to be paired with one another, and so the communication or signal exchange is going to occur over a secure link. So it's occurring in a one-to-one topology between the two Bluetooth devices. With Bluetooth channel sounding, there are two device roles. These are new device roles. There's the initiator. This is the device wishing to calculate the distance to the other device. And then there's the reflector, which of course is responding to the initiator. And then a couple points to make just about the channel sounding operation, how it works kind of at a high level. So the application layer, that's what provides the configuration choices and preferences that are suitable for the two devices. And that's using HCI commands. Kind of obvious, but to just point it out, both LE controllers have to support the channel sounding feature. And then these channel sounding procedures consist of these signal exchanges that produce, when you're talking about at least phase-based ranging, at least that produce phase and time delay data. And so what kind of happens at a high level is something like this. So the distance ends up being calculated by the algorithm, which Alec's going to talk more about. And that's based on data that's gathered from the signal exchange, and the data gets passed from the LE controller, up to the application layer via ACI events. And so that's just a little bit of a summary of how channel sounding works at a high level. And then taking just a little bit closer look at phase-based ranging. The phase-based ranging method is used to produce the high accuracy distance measurements. How it works at a high level, you have this initiator device, the smartphone. It's going to choose a frequency, say frequency 1, and then that device is going to send the signal to the reflector device, which then returns the signal. And so what's happening here is the phase and the amplitude of the communications channel are what's being measured. So then this process is repeated across multiple channels, multiple frequencies, and the distance between the devices is calculated based on the phase differences between the transmitted and received signals over those frequencies. All right, there is a secondary ranging method called round-trip time, or RTT. RTT can be used to measure distance, but really its purpose is to increase security. So we say that RTT is used for secure distance bounding. With RTT, unlike phase-based ranging, where you can potentially, a complex attack on phase-based ranging, you could change the phase. RTT is based on time of flight, and time can't be reversed. So RTT can be used as a countermeasure against some of these sophisticated man-in-the-middle relay attacks. And then the sequence of how it works, if you're familiar with time of flight, it's fairly obvious, but with Bluetooth channel sounding, there's an RTT mode where you can choose to exchange these cryptographically scrambled packets. If you went that route, so the cryptographically scrambled packets are exchanged between the initiator and reflector. Distance is calculated based on that round-trip time. And then so these calculations can be used to both validate the PBR measurements and then also identify the wireless ranging attacks. And so that's why we say that combining phase-based ranging and RTT can be what helps enable accurate and secure distance measurements. Okay, so one topic that I want to cover is not necessarily part of the spec, although it is specified that there's support for multiple antennas, but I want to clarify or explain the support for multiple antennas, because there's other Bluetooth features where you need like antenna arrays, like direction finding. With Bluetooth channel sounding, there are multiple antenna options, like the slide says, flexible. So the point I want to make is that with one antenna on each device, you can get these really good results, which I have some data to show you about that. And then the image shows these different antenna configurations that are supported. So one antenna on each end, one antenna path. You got 2 and 1, then you're going to have 2 paths. 3 and 1 is going to be 3 paths, and then 2 and 2 is 4 antenna paths. And then so obviously multiple antennas supported, maximum 4 antennas. The benefits of having multiple antennas, multiple paths, you can of course get better distance measurement accuracy, but a couple of important points for like real world type scenarios is that multiple antennas can provide alternate path options that can mitigate interference. And then also having multiple antennas can help you better distinguish the shortest path when these reflections that are present are that are more common, or very common, I should say. All right. Also, in the higher layers, there's a ranging profile and service specification. Just as a refresher or reminder, just high-level description. Like a profile basically defines the rules and configurations for data exchange, ranging data exchange in this instance, and then the service contains the state data, supports specified operations for that data. And then so if you want to define these together, the ranging profile and service are a pair of GATT specifications, and they define the interoperable exchange of ranging data for distance calculation by the application. Albert's going to tell us all about that. And so the simple use case example to continue to build on that is you have the smartphone, which is functioning as the GATT client. It's going to request the ranging data from a door lock, the GATT server. This door lock then is going to forward the ranging data to the smartphone through the ranging service. And then the application running on the smartphone processes the data to produce the distance calculations. One other point on the ranging profile and service, sometimes in Bluetooth technologies, these profile specifications are use case specific. The ranging profile and service are not. Support digital keys, Bluetooth locks, find my type devices, control solutions, and more. And now distance measurement algorithms, just to hopefully set up our next talk. Bluetooth channel sounding provides, I kind of alluded to this already, provides standardized techniques to determine signal phase and time delay information, which is used by a distance measurement algorithm to calculate distance. The Bluetooth channel sounding feature itself does not define a specific distance measurement algorithm. Here's the key reason. The appropriate algorithm configuration or setup may vary depending on the application or implementation. Thus, the inventors of Bluetooth channel sounding felt it would be best to exclude the algorithm from the Bluetooth channel sounding feature specification. So that means that the distance measurement algorithm can be sourced or developed independently. And on one other note, algorithm selection does not impact interoperability. Okay, now to the part that I've personally been looking forward to sharing with you. So we did have some member companies conduct this performance testing for us. This was pre-standard early implementation testing. Samsung LSI, Lambda 4, an algorithm provider partnered to provide these test results. For the testing, they used these prototype smartphone. You can see the image of it right here, actually. The testing environment was an outdoor parking lot with clear line of sight. See what else? The devices were stationary, mounted at about a meter, so about waist height. The tests were run with 1, 2, and then 4 antenna paths. And then the first 2 tests were run at a 0 dBm, typical power setting for a Bluetooth device. There was a third round of testing that was run with where they cranked the power up to plus 10 dBm. And then they used a 90% statistical distribution for absolute error reporting. All right, before I share the data, I do need to point out that these were, again, early implementation results, pre-standard prior to the channel sounding feature being launched. And so results are subject to change. There's a couple of results that are kind of like head scratchers. But with that said, let's take a look at the data. All right, to start off with, this first round of testing was with 1 antenna on each device, so 1 antenna path. The power setting was 0 dBm. Let's see how this works. And then, so at 1 meter, you see that we were spot on. Exactly the distance that the devices were apart from one another is what was measured. 5 meters, 20 centimeters. Our outlier for this round was at 10 meters. I say that because you see then at 20 meters and in 50 meters, the results improved. And at 50 meters, plus minus 20 centimeters of the actual distance. So which excellent and consistent performance, especially for like a narrowband technology. And then the second row, back pocket, the phone was then was placed in someone's back pocket, and an individual stands in between the 2 devices, or so basically interference. And so here, the results were still quite good. Our outlier was at 5 meters, not a real good result there, but then a great result at 10 meters, and then 20 meters good, and plus minus half meter at 50 meters, and that's with back pocket scenario testing. So really happy to see that. So then the next one was a setup where one device had 2 antennas and the other device had 1 antenna. Again, the power was set to 0 dBm, so a really typical power setting, transmit power setting for Bluetooth devices, even battery powered type devices. And then, you can see it, but, spot on again at 1 meter, great result at 5 meter. And then, pushing out a little farther, 20 meters and 50 meters, really good result within 10 centimeters of the distance, of the actual distance. So super, super good result. And then in the back pocket setting, we had more consistent performance, additional path. So, less than half meter at 1 meter, and then half meter at 50 meters, and then the results in between were quite nice. And then so for this last test, some more high-end type would be more high-end type implementation, where each device had 2 antennas, so 4 antenna paths. They did crank the transmit power up to plus 10 dBm. And then here, again, really good results though. Interestingly, the result wasn't quite as good up close, but then really steady across up to 50 meters, 10 centimeters at 20 and 50 meters. So really steady up line of sight. So, but then in back pocket, I want to say that, the results were pretty similar to the 2x1, but 20 centimeters at 1 meter, half meter at 50 meters, and just overall really steady performance over the distances that were tested. All right, and so now this slide is one where we just talk a little bit about where we are as far as support for the Bluetooth channel sounding feature in the market. There are enabling technology products, chips, module stacks that support Bluetooth channel sounding today. Those are out there. We're expecting end-use products to start coming onto the market in 2025. The most exciting thing and interesting thing about market progress, though, to me, is that support is indeed coming to Android 15, QPR3, including the APIs. And I've provided the link, which I'm sure most of you may be familiar with, the Android code search on Android.com. If you were to search for channel sounding, you would find that ranging service client and server framework is there today. There's also a channel sounding test app. And so I don't know of any Bluetooth feature that's had this level of support this quickly on the platform side. So we're super excited about that. It just kind of helps tell the story or support the story that Bluetooth channel sounding is going to have a big impact on these Bluetooth connected products. So now, let's switch to some of the upcoming features, and I'll go pretty quick here. So one specification project that's in progress, I should say, is the High Data Throughput project. This is a project to increase the throughput or max data rate supported for Bluetooth LE technology up to 8 megabits per second. So doing this is going to enhance, initially it's going to enhance a lot of these LE audio type use cases. You'll be able to have more audio streams, you'll be able to get better audio quality, and then it's obviously going to improve operations with respect to like data transfer type stuff or like firmware upgrade. So that's going to improve those use cases. And then another project that's underway is the ultra low latency HID project. This is targeting the HID devices again. Here we're looking to increase polling rates up to 1 kilohertz and then move latency down to 1 millisecond. So that's going to enhance these gaming type use cases, controllers, keyboards, mice, looking to make them nearly as responsive as wired or proprietary type of devices that are available on the market today. And then the last feature to touch on is the higher frequency bands project. This is a project that's looking to enable Bluetooth LE operation in higher mid-band spectrum. That's targeting parts of the 5 gigahertz frequency band and the 6 gigahertz unlicensed band, actually both unlicensed, to be clear. And so we say that the higher frequency bands, really the purpose of it is to set up Bluetooth technology for the next 25 years of performance enhancements. And then the takeaways to leave you with, now, Henrik's going to hit on the technical part, but Auracast adoption is continuing to accelerate. If you follow the Bluetooth SIG social channels, you'll probably see announcements from us about additional commercial progress that's happening in the coming weeks and months. Then channel sounding, you're going to see end products come on the market that support channel sounding in 2025. And then HDT is going to bring data rate or throughput up to 8 megabits per second. The ultra low latency product is going to increase the polling rates, make these HID devices more responsive. And then the higher frequency bands project is going to enable the next generation of Bluetooth innovation. So that's what I have to share with you today. So thank you.